Hi, we'll be starting with another topic which is called as the power system analysis, in which we'll be starting with the generation part, followed by the transmission part, and then the distribution part. And apart from that, we'll be discussing about the types of circuit breakers and relays, all that in the later part of the sessions. So, starting with the type of hydroelectric plants or the generation. Generation of electricity. How we will be generating the electricity, that is a very important point in power system analysis. And based on that, different type of arrangement we have. And those arrangements are normally known as the hydropower electric plants. Another is called as the thermo plants, nuclear plants, diesel plants, pumped storage plants, and so on. Different type of plants are there. Starting with a very basic part, that is called the hydroelectric plants. In a hydroelectric plants, basically everybody knows what happens, but for a brief explanation, we can understand that in hydro plants, water is stored in some place, or running water is actually passed through a turbine, which is actually connected to the generator or the synchronous alternator. And when the turbine moves, its shaft is actually coupled with your generator, and the generator produces electricity. Now, whatever be the flow of the water, it depends on that how much electricity will be produced. And the type of the turbines we'll be discussing in this chapter, and the terminology which are normally being asked in objective type of questions, we'll discuss that, how power is generated, we'll see that, what type of different hydroelectric plants are available, we'll see that. Starting with the selection of the site, it is very important in any power system analysis that the selection of the either the hydroelectric plant or the thermoelectric plant is very necessary. So first of all, selection of the site. In the selection of the site, first of all, the thing is that since it's a hydroelectric plant, that there should be ample amount of water available. The quantity of water available is very important. And how the quantity of water is taken actually by the way that we know that water is coming by our rainfalls, by the precipitation, and water is even getting evaporated from there. So we have some thing calculation which is left is called the runoff. So we can say that R runoff runoff is equals to precipitation minus the evaporation. We know the precipitation. What is precipitation? Precipitation is what which is actually coming from the rainfall, and evaporation is which is getting evaporated due to heat. So actual runoff, actual water quantity available at the site would be the runoff quantity. This is a very important term in hydroelectric plants. So we have, for runoff, we should have a record of the graph, and hydrology also, which we will be looking after in few minutes. Apart from that, very important thing is selection of the site, that the shed should be able to store, or we can say that the storage of the water, water behind the dam is very much important. Apart from that, last very important thing is head. Head of the water is very important in production of the power. How? What is actually head? Head is the level of the water up to which we can store it behind the dam. Suppose this is my dam, and I have water behind the storage here up to this point. So this would be known as the head of the plant. Isn't it? No. This would be known as the head of the plant, not this one. At the height which my dam is actually constructed from the ground, that would be called as the head of the ground. This is whatever is below this is called the reserve capacity, which is always there for the generation. Since below this water will not be able to flow towards this side, but it will be always there to give a water capacity, that is the reserve capacity. We will not go into that. The discussion is about the head. So this is the head, which is actually the water is up the level. So it is how it is important that we know that we have learned a formula that P is equals to mgh, and we have studied one more formula for kinetic energy, that half mv square. So whatever with the head mgh, that will be getting converted into your kinetic energy half mv square. So whatever with the height of the water, that is the potential energy of the water, and that is actually converted into the your kinetic energy, and then from kinetic energy to your electrical energy. So what are maximum your mgh, so maximum here will be your power generated. We have a formula for this also. For head, we know that the power produced is equals to 0.75 divided by 736 into Q W N H. What is Q? What is W? What is N? What is H? Q is actually the density of the water. This density is fixed for a type of water, for a place. This density is almost fixed, or even if it is fluctuating, then there will not be any much difference in the density of the water. W is your efficiency. W is your efficiency. Sorry, Q is your. Sorry, Q is your discharge. This is W is your efficiency. W is your density of the water. Discharge per meter cube, or you can say meter cube per second. How much discharge, how much water is flowing actually. That is called the discharge. Density of the water. And is the efficiency of the plant. Efficiency of the plant, and H is the head. So H is your head of the plant. So from this formula we can say that this is almost a constant. Q is also almost a constant. W is also a constant. And for a plant, efficiency is also a constant, or even if it is not, then there is not much difference between a hydroelectric plant efficiency. So we can directly say that your power is directly proportional to your head. So this is a very important relationship. Power, generated power, is directly proportional to your head. So please remember this thing for objective type of questions. Now, coming to another part of the selection is called your distance of the power station site from the load center. Now, if the load center is very much near to the hydroelectric power plant, there may be chances of flood and all that. And one more thing, when the hydropower plant is made, it occupies a lot of area, and there must be a safety area for which that the water which is actually getting stored in there should have must be actually in a safe value, so that even the discharge of the water away from the your dam, behind the dam, is not a danger for a living person or for a society. So this is very important that the load center should be far away from the locality or from the living environment, but it should not be so far that that will be putting an additional cost on the transmission part. So that it should be on a minimum value, and that it is not a dangerous for living persons, as well as it should not be far away from the accessibility of the persons. So the final point is the distance. So these are normal things, but the thing which is very important, that this formula here, runoff, and the head, these are very important for the selection of the site when we talk about the selection of the site.